Turn off every sound around you right now. No music, no podcast, no background noise humming from another room. Just sit there for a moment in complete silence. Notice how quickly it starts to feel uncomfortable. Notice the urge to reach for your phone, to fill the space with something, anything. That discomfort is not random, but the real reason silence feels so unsettling and so quietly powerful has almost nothing to do with boredom. It has to do with what your brain is doing the instant the noise stops. Most people cannot remember the last time they sat through a truly silent stretch of their day. There is music in the car, a podcast during the walk, a show playing in the background while dinner gets made, a phone glowing on the nightstand right up until the moment sleep takes over. Even the gaps that used to belong to silence, waiting rooms, elevators, the walk to the mailbox, have been quietly filled in by something. This did not happen through any single decision. It simply accumulated, one convenient piece of stimulation at a time, until true quiet became rare enough that most people barely notice its absence anymore. Start with a strange fact. Most people, when placed in a completely silent room for even a few minutes, report feeling restless, anxious, or oddly exposed. One well-known psychology study found that many participants, left alone with their thoughts in a quiet room, chose to give themselves a mild electric shock rather than sit in silence with nothing to do. Silence, it turns out, is not neutral. For a brain wired for nearly constant stimulation, it can initially feel like a kind of threat. But here is where the story reverses completely. While silence feels uncomfortable on the surface, underneath that discomfort, something remarkable is happening, something that noise actively prevents. In 2013, the researcher Imke Kirsta, working at Duke University, ran an experiment that was not originally designed to study silence at all. She was investigating how different types of sound affect the brains of mice, comparing white noise, pub calls, classical music, and periods of complete silence. What she found, almost by accident, was striking. The mice exposed to 2 hours of silence per day showed significantly more new cell growth in the hippocampus, the brain region deeply involved in memory formation and learning, compared to mice exposed to any of the sound conditions, including music. Silence itself, not any particular sound, appeared to be the condition most associated with new neuron development. Kirsta's team was careful about what this did and did not prove, but the implication was striking. The brain does not simply tolerate silence. In some very real sense, it may need it. It is worth being precise about what this study did and did not show. Kirsta's team followed the newly generated cells for several weeks to see whether they survived and integrated into existing neural circuitry rather than simply appearing and quickly dying off, which is a common fate for many new brain cells. A meaningful portion of the cells generated during the silent condition did mature into functioning neurons. This mattered because it ruled out the simplest alternative explanation, that silence was not creating growth so much as it was simply less stressful than the sound conditions, which could have suppressed cell death rather than promoted new cell birth. The data suggested something more active than mere stress reduction. Silence appeared to be doing something constructive, not just removing something harmful. This connects to something researchers have understood for decades about how the brain behaves when it is not actively processing external input. The neuroscientist Marcus Reichel helped identify what is now called the default mode network, a set of interconnected brain regions that become highly active specifically when a person is not focused on a task or an external stimulus during daydreaming, reflection, or unstructured rest. For years, scientists assumed the brain was essentially idling during these quiet moments. Rachel's research overturned that assumption. The default mode network consumes a significant amount of the brain's total energy, comparable to focused, effortful thinking, and it plays a critical role in memory consolidation, self-reflection, and creative problem-solving. In other words, the moments when your brain appears to be doing nothing may actually be some of its most metabolically active and psychologically important work. Constant external noise, constant stimulation, crowds out the very conditions this network needs to activate. Reichel first noticed this pattern almost by accident, while using brain imaging to study what happens during focused tasks. He needed a baseline measurement, a resting state to compare active thinking against, and expected that baseline to show relatively low, unremarkable activity. Instead, the resting baseline showed a consistent, organized pattern of high activity across a specific network of regions, one that actually decreased when a person switched to a demanding external task. That inversion was the real discovery. The brain was not resting when left alone with silence and no task. It was switching into a different, equally demanding mode of operation, one aimed inward rather than outward. Every time a podcast, a notification, or background chatter interrupts that inward-facing mode, the brain has to abandon whatever internal processing it had been running and redirect its resources toward the new external input instead. There is also a measurable physical dimension to what silence does to your body, not just your brain. The cardiologist Luciano Bernardi conducted a study examining the cardiovascular and respiratory effects of music and, almost as a side finding, the pauses between musical pieces. Participants were monitored for blood pressure, heart rate, and blood flow to the brain while listening to various pieces of music interspersed with short periods of silence. The most physiologically relaxing moments in the entire study were not during the calmest music. They occurred during the silent pauses between tracks, particularly when those pauses lasted longer than a couple of minutes. Blood pressure dropped. Heart rate slowed. Blood flow to the brain's circulatory system shifted in a pattern associated with relaxation. Silence, in Bernardi's data, produced a stronger relaxation response than even deliberately soothing music. What made this finding especially interesting is that it emerged as a surprise, buried inside a study designed to measure something else entirely. Bernardi's team had expected the music itself, particularly slower, calmer pieces, to be the primary driver of relaxation, since that assumption underlies a great deal of music therapy research. Instead, the silent gaps the researchers had included mainly as experimental controls turned out to produce the most pronounced physiological shifts in the entire dataset. The effect was strong enough and consistent enough across participants that the researchers highlighted it as a finding in its own right rather than a footnote. The body, it seemed, was not simply calmed by the absence of stimulating music. It was actively responding to the silence itself as a distinct physiological event, one with measurable cardiovascular consequences of its own. Put these three findings together and a clearer picture starts to form. Silence is not simply an absence, a gap where sound should be. It appears to be an active state, one that allows specific biological processes, new cell growth, deep memory consolidation, cardiovascular recovery, room to occur that constant stimulation actively interferes with. This helps explain why modern life, filled almost wall-to-wall with notifications, background music, podcasts playing during every commute, and screens glowing in nearly every quiet moment, might be doing something more significant than simply keeping you entertained. It may be crowding out a biological process your brain and body were built to rely on regularly. There is an evolutionary logic underneath this too. For nearly all of human history, true, prolonged silence was common. Nights without artificial light, long stretches of solitary walking, hours of repetitive manual work all created natural windows of quiet that modern life has largely eliminated. Your ancestors were not seeking out silence as some deliberate wellness practice. It was simply the ambient condition of a huge portion of their waking life. The brain systems that rely on those quiet windows, the neurogenesis, the default mode network, the cardiovascular recovery, evolved inside an environment that guaranteed their presence. Modern life removed the guarantee, but never removed the underlying need. Consider how different that ancestral soundscape actually was from the one you live in now. A long walk between settlements, hours spent tending a fire, the repetitive motion of grinding grain or weaving cordage. All of these tasks occupied the hands and the eyes without occupying the ears with anything beyond wind, footsteps, or distant birdsong. The brain evolved to treat that kind of low, unstructured auditory environment as the default backdrop of an ordinary day, not as a rare and precious commodity to be scheduled in. It is only in the last handful of generations, an evolutionary blink of an eye, that constant curated sound, music piped into stores, notifications chiming through the day, conversation available at the tap of a screen, became the default instead. Your biology has had essentially no time to adjust to that reversal. This reframes the discomfort you feel when the noise stops. That restlessness is not a sign that silence is bad for you. It may be closer to the opposite, a kind of withdrawal. The same way a body used to constant sugar intake initially reacts poorly to its absence, even though the absence is what it actually needs. The urge to immediately fill quiet with a podcast, a notification check, a burst of background music is not necessarily curiosity or engagement. It may simply be discomfort, misread as boredom, prompting you to shut down a process your brain was in the middle of running. None of this means every moment of your day needs to be silent or that noise itself is harmful. Music, conversation, and sound are not the enemy here. But the near total elimination of silence from modern daily life, the instinct to fill every commute, every walk, every quiet evening with input, may be quietly cutting off a resource your brain has relied on for its entire evolutionary history. Even a short, deliberate stretch of quiet, a walk without headphones, a few minutes before bed with nothing playing, appears to be enough to let these systems engage based on how quickly the physiological changes showed up in Bernardi's data and how consistently the neurogenesis effect appeared after just 2 hours a day in Kirsty's mice. This is not a demand for hours of monastic quiet. It is a much smaller ask than that. So the next time you find yourself reaching for your phone the moment a room goes quiet, you will not need to call that restlessness boredom anymore. You will know exactly what is happening. Your brain, for one uninterrupted moment, was finally being given the space it has always needed to do some of its deepest, quietest work.